So in this video, we'll have a look at Newton's second law. So, Newton's second law, it makes a connection between force, mass, and acceleration. So, this is the formula we're going to use. F equals ma, where F is newtons, mass is in kilograms, and acceleration is in meters per second. So, you can tell just from the equation that newtons is measured in kilograms, meters per second. It's called unit analysis. It's very important. Also, we know that acceleration is equal to velocity minus final velocity minus initial divided by time. So basically this is also an equation. F net, there should be a net here too. The net force is equal to mass times V minus U over T. And when you learn momentum, you'll realize that this is equal to delta momentum over delta T. But we'll cover this in our next video. So let's get straight into an example. So if this question says, calculate the net force causing a 5.5 kilogram mass to accelerate at 3.75 meters per second west. So, force is equal to mass times acceleration. Mass is in kilograms, that's 5.5, and acceleration is in meters per second, which is 3.75. So if you put that in your calculator, you get 20.625, and the units in newtons. And always remember to put the direction in, because force is a vector, so it needs a direction. Let's try another example. Let's say there was a question saying calculate the final velocity, so we're looking for V, of a 225 kilogram scooter that accelerates for 2 seconds from west due to a force 2,430 newtons north. So first, call north either positive or negative. I'm going with positive. And this is mass, this is time, this is initial velocity, and this is force. So this question will need this equation, m times v minus u over t. So m is 225 kilograms, velocity is just v, because we don't know. U said it was at rest, so that's 0, so that just becomes v on top, and time is 2 seconds. And force, or the net force, is 2,430. So V is equal to 2,430 over 225 times 2. And that is equal to 21.6 meters per second. Okay, let's try another one. And this one will be an example of multiple forces acting on one body. So it says a swimmer whose mass is 75 kilograms applies a force of 50 newtons as he starts a lap. The water opposes his efforts to accelerate with a drag force of 20 newtons. So this is drag. This is him swimming. And it says calculate his initial acceleration. So there are two forces acting on this. F1, which is 50 newtons. Let's say this is the end, the start. Let's say going this way is the positive direction. That means F1 is a positive, because he's going towards the end. Now F2 is the drag force, so it's going this way, which means it's negative. So F2 is equal to negative 20 newtons. And to find the net force, we just add force 1 and force 2. So this becomes 50 minus 20, which is 30 newtons. Okay, now we use Newton's second law. F net equals mass divided by A. So A is equal to F net over mass. So acceleration is equal to 30 newtons over 75, which is equal to 0.4 meters per second per second. Okay, let's try one more question. This will be a pulley question, and I'll try to draw a diagram here. So there's a table, this, the leg, and here's a pulley. And here's a cart attached to a string to a pulley, and there's a weight of 2.5 kilograms, and the cart is 1.5 kilograms. And the question says, a 1.5 kilogram dynamics cart is connected by a cord to a 2.5 kilogram mass as shown. The cord is placed over a pulley and the mass is allowed to fall under the influence of gravity. And it says, calculate the acceleration of the cart, assuming that the cart is unhindered by friction. So we need to identify the force acting on this apparatus. And the only force acting here, because there's no friction force or air resistance, is the downwards force by gravity. So force net equals ma. So this object is being pulled by gravity, so m is equal to 2.5. And acceleration due to gravity is 9.8. So 2.5 times 9.8. Oh no, sorry, is equal to 24.5 newtons. So this is the net force. So now we're going to find the acceleration of the cart. So the net force has to accelerate both the 2.5 kilogram weight and the 1.5 kilogram cart. So since it's accelerating both of them, we need to add their masses. So mass 1 plus mass 2 is equal to 4 kilograms. So if the mass is 4 kilograms, the net force is 24.5 newtons, and acceleration is unknown. We use the formula A is equal to F net on m to find the acceleration. So it's 24.5 over 4, which is equal to 6.1 meters per second. And always add a direction, so the cart is getting pulled towards the right, so we're going to put a right at the end of our answer.